All right, let's look at number 2. Let's graph y equals 1/2 times the absolute value of x plus 1 minus 3. So in order to graph this, we need our vertex and we need our a value. So our vertex here, remember we look at h comma k. Well, our h value is always in the absolute values, but what's special about it? We take the opposite. So I see x plus 1. For my vertex, I take minus 1. Then for my k value, I take exactly what I'm given, that -3. We only take the opposite of what's in the absolute values. Well, what's my a value here? It is 1/2. And what does that tell me to do? That tells me to go up 1, and then it tells me to go over 2, left and right. We'll go up 1, over 2, left and right. So now let's go ahead and graph it. We're just going to put our vertex on our graph. So we go to -1, -1, 2, 3. And our a value, which is kind of like our slope, tells us to go up 1 and over 2, right and left. So I'm going to start right. I go up 1 and over 1, 2 to the right. Up 1 and over 1, 2. Up 1, over 2. But we're not done. We should have a V shape, so we go left. We go up 1 and over 2 left, up 1 and over 2 left. So make sure that you don't stop graphing until you get some type of V shape. So here is our function, our graph. Now we need to do the domain and range, and we need to write down our transformations. So on this column, we're doing interval notation for the domain and the range. Now, what's our domain of every single absolute value function? It goes forever left, forever right. So our domain is all real numbers. The way we say that in interval is it goes from -infinity to +infinity every single time. Now for the range, we look up and down. In this case, we have a minimum value because it opens up. This is the lowest y value of my graph. Well, what is that minimum value? Our graph starts at -3. So it starts at -3. I'm putting a bracket because that's a closed circle. And then it goes up forever and ever. Well, where is that? Where are those arrows heading? They're heading to +infinity. So it goes from -3 to +infinity. Now we need our transformations. First thing I ask is, was it reflected? The answer is no, because that's a positive a value. Next thing I ask is, was there a shrink or a stretch? In this case, yes, because our a is something other than 1. So now we look at this 1/2. Is 1/2 greater than 1 or is it less than 1? Well, it is less than 1. So that means this is a shrink by a factor of 1/2. Whenever we have a shrink or a a shrink or a stretch, we write what the factor is that it was shrunk or stretched. And then next thing I ask myself is, was it taken to the left or to the right? So remember that usually our parent function is here at 0, 0. So if I start at 0, 0 to get from 0, 0 to our new function, did we go left or did we go right? Yes, we went left. How many units? 1 unit. So we went left 1 unit. And what else happened? Did we go up? Nope, we went down 3 units. So we went left 1, we went down 3. And these are all things we should be able to tell just from the function as well, which we'll do at the bottom. One last thing I want to look at before we move on is look at that range. We always get our restriction, our max or our min value, from our vertex. It's the y value of our vertex. So if my vertex has a -3, that's going to be either my max or min. I know that in this case it's a minimum value. It's the lowest point because it's opening up. Because I have a positive a value, that means it's opening up, which means that this is a minimum value. Okay, so let's move on to the next one. I want you to try this one on your own and then check your answer with me. So here is our absolute value function. We've got y equals 3 times the absolute value of x minus 3 minus 4. Go ahead and pause the video and try to do this one on your own and then come back and check it with me. All right, now that you tried it, we need to find our vertex. We need our a value as well. So for my vertex, I take the opposite of that x value. That's going to be a positive 3. I take that k value, which is negative 4. What's my a in this case? It is 3. So let's graph it. We go to positive 3, negative 4. My a value is 3. So what does that tell me to do? It tells me to go up 3 and over 1 left and right. So I start at my vertex and I go up 1, 2, 3, over 1 right. Up 1, 2, 3, over 1. But we're not done, we have to go left. We go up 1, 2, 3, over 1, up 1, 2, 3, over 1. So here's my function. Make sure that it is some type of V shape. And let's do our domain and our range. We are in the section where we're doing set builder notation. So what's our domain every single time? It is all real numbers. So in set builder, that's x is an element of the reals. Then what's my range? For my range, I look for my max or my min value. In this case, I have a minimum. There's a lowest point on my graph. My graph starts here at negative 4, and it goes up forever and ever. So that means my range is going to be y is an element of the reals such that y is something with negative 4. Are we graphing the numbers bigger than negative 4 or less than negative 4? It is greater than or equal to. We're starting at negative 4, going up forever and ever. So there's our range. Now let's look at the transformations and list them. First one, was there a reflection? No, because it is opening up. Next thing, is there a stretch or a shrink? The answer is yes. Look at that a value. It's 3. Is that a stretch or a shrink? That is a stretch by a factor of 3. Next thing we ask ourselves is, did we go left or right? Well, remember, our parent function always starts at 0, 0. So to get from 0, 0 to our new function, we actually went to the right 1, 2, 3 units. So we went right 3 units. And what else did we do? We went down 1, 2, 3, 4 units. Down 4 units. So those are the transformations for this function. Let's look at number 4. Once I write it out, I want you to try it on your own and then check your answer with me. So we've got y equals negative absolute value of x plus 2 plus 3. Try it and then start the video back. All right, now that you tried it on your own, let's do the vertex and the a value. Well, our vertex here, we take the opposite of the inside, so that's going to be a negative 2. We take exactly what we're given on the outside, that's a 3. So our vertex is negative 2, 3. What's my a value? All I see is a negative sign. Well, when there's no number for a, we know there's an implied 1, so this is a negative 1. What does that tell us to do this time? Are we going to go up? No, we're going to go down 1 and over 1 left and right. It's down because it's negative. So let's do that. We're going to go to negative 2, positive 3. Our a value is negative 1, so we are going down 1 and over 1. Down 1, over 1. Down 1, over 1, etc. Remember, it has to make a V, so I go left as well. Down 1, over 1, down 1, over 1, down 1, over 1. Always connect our dots because it's continuous with arrows on both sides. Now that we've got our graph, let's do the domain and range. We want these in interval notation. Well, what's my domain every single time? It is all real numbers. It's going from negative infinity to positive infinity. So that's how we write it in interval notation. Now we want our range. In this case, we have a maximum value because we have a highest point on our graph. So I look down at my graph and looking at my y values, where are these arrows heading? They're heading down to negative infinity. So my graph starts, my y's or my range starts at negative infinity, and it goes and it goes and it stops at 3 with a bracket because we've got a closed circle. Let's list the transformations. What was the first one we always ask ourselves? We say, was it reflected? The answer is yes, finally yes, because it is a negative 1. So I'm just going to say it was a reflection. All right, next thing we ask is, was there a shrink or a stretch? The answer is no, because this is a -1. If it's anything other than 1 or -1, then yes, there's a shrink or a stretch. Now we say, did it go right or left? So we always look at the origin because that's where the parent function starts. To go from here to here, did I go left or right? Yes, I went to the left 2 places. So I went left 2 units. All right, to go from here to here, what else did I have to do? I went up 3 units. Up 3 units. So we're always looking at from the parent function, which is at 0, 0, to our new vertex. So there is number 4. Let's head to number 5. We've got y equals -4 times the absolute value of x minus 1 plus 5. Go ahead and pause the video, try this one, and then come back. All right, let's look at it together. We need our vertex first. Well, our vertex, we take the h value, we do the opposite, which is going to be +1, and then we take our k value, which is 5. So there's our vertex. What's my a value in this case? My a is -4. And what does that tell me to do? It tells me to go down 4 and over 1 left and right. Down 4, over 1 left and right. So let's go ahead and graph it. We're going to go to 1 and then to 1, 2, 3, 4, 5. So here's my vertex. My slope here, or my a value, tells me to go down 1, 2, 3, 4 and over 1. Down 1, 2, 3, 4 over 1. So there's my right side. Now I need left. So down 1, 2, 3, 4 over 1. Down 4 over 1. So here's my absolute value function. Let's look at our domain and our range and the transformations. So we're doing set builder in this column. Our domain, every single time, it's going from -infinity to +infinity, or in other words, all real numbers. So x is an element of the reals. Now my range. In this case, I have a maximum value because it is opening down. My maximum value is here at 5. So I'm looking at my y values that are covered. I'm starting at 5 and I'm covering all the numbers that are smaller because it's going down. So when I write my range, I've got y as an element of the reals such that y is something with 5 because 5 is where it's the y value of the vertex. Well, are we graphing the numbers greater than or equal to or less than or equal to? It is less than or equal to. Lastly, our transformations. First thing we ask is, was it reflected? The answer is yes, because it is opening down. That's a reflection. Next thing we ask is, was there a stretch or a shrink? This is probably the trickiest for some of us because our a is -4. Remember what we said on the front of the page. We said that if the a value, if the absolute value of a is bigger than 1, then it's a stretch. This is a -4. The negative tells us reflection. After that, we don't care about the negative. 4 tells me it's a stretch. So this is stretched by a factor of 4. A few things to notice. This is a stretch and not a shrink. Even if it's negative, that doesn't mean it's a shrink. It just means a reflection, and then we look at the absolute value of that number. The absolute value of this is 4. 4 is bigger than 1, so that means it is stretched. And notice I said a factor of 4 and not -4. Next thing we need to see is that we moved it to the right 1, and we moved it up 5. I've just got one more little video for you to watch, and then we'll be done with these notes.